Here I will explain you Kirchhoffs second law. This is also termed as loop law or voltage law. So previously it was junction law. The meaning is it is applicable across junctions. So here it is applicable for loops, and this is also taken as voltage law. Okay, because here we are talking about voltage. Previously it was current law. Okay, now according to the rule, it is in a loop of electrical circuit, sum of potential difference across different element is 0. So previously, in previous video, I have explained you what is loop. So here how many loops are there? From A, I can go in this direction. Through B, this is one loop. And another loop is from A, I can go in this direction and reach back A. And from A, I can also go in this direction and reach back A. So there are 3 loops possible. And other loops is also possible. You can find different combinations. Clear? Now, there are some standards to be taken here while measuring the value of potential difference. One thing is, when current is passing through, now before that, one thing you have to be clear with, that is before applying Kirchhoffs second law, you should apply Kirchhoffs junction rule first. That is, first rule have to be applied first, then only you should start doing or applying Kirchhoffs second law. Now, in Kirchhoffs second law, by the time you apply Kirchhoffs second law, you will be knowing all the current because you have already applied Kirchhoffs first rule. So, let's say for example, you have applied the junction rule and got the direction of current here as in this direction I1 and here as in this direction I2. So if at all, if you don't know, if the direction of current is not given in the question paper, you can also take as from positive, wherever the power sources are there. Here cell is a power source, right? From the positive, you can assume that current is coming in this direction. Here also from positive, you can assume that current is coming in this direction. If at all, if this is wrong, if the current is going in this direction, at the end in your answer, you will get I as a negative value, which means your assumption was wrong. But only the direction is wrong. Every other values will be the same. The numericals, the numbers will be same, but the directions will be wrong. So you can take an assumption, you can assume in one way. If at all, if that is not the actual direction of current, you will be getting the value of current as, for example, here if you are getting I as -2, which means it is the 2 ampere current here, but the direction is in this way. Now we will first take I1 from this one as in this direction, from this power source as in this direction. We don't know whether it is correct or not, but we will take in this way. Now we will apply junction rule here. What is that? I1 enters, I2 enters. Total entry at the junction is I1 plus I2. So total current leaving the junction will be I1 plus I2 here. Now again I1 will come, I1 plus I2 will come here. Previously I have explained you a very important concept, that is concept with branch. Branch is nothing but in between junction. So now this is all the elements in between the junction from A to B. This is one branch, this is another branch. Now I also have told you current in all the elements across a branch will be same, which means current through this one is equal to this one is equal to this one is equal to this one, which means if I1 is going in this direction, I1 is coming through the bridge, entering at the bridge and going in this direction. Clear? Branch, sorry. Now here, if I2 is entering, going in this way, which means I2 is the current that has entered the branch and going in this direction. Now that has came and combined here as I1 plus I2 and going in this direction. From here again I1 is split, I2 is split. See, I1 plus I2 enters and out of that I1 and I2 leave. So leaving is I1 plus I2, entering is I1 plus I2. See, so junction rule can be applied to all junction and even loop rule can be applied to all loop. Now here sum of potential difference. Now to sum, you should know what is actual potential difference. Now potential difference in between the cell will be taken as positive and also can be taken as negative depends on how current is passing through this. Okay, from negative to positive, when current pass, we will be taking it as positive, and from positive to negative, when current pass, we will be taking it as negative. Okay, this is one standard taken. Now another standard is, whenever we are taking a loop, we will mark the direction of the loop. That is from A, let's say our loop is A, this is EMF 1. So A, for a loop of A, E1, R, B, then resistance, then A. What is the direction? This is the direction. Right. Now we have to start from one point to apply loop rule. So we are starting from A. Now what is happening? We are going through this one, and now keep your finger moving across the battery and resistance. Now when we are keeping our fingers in this way, we are moving the finger from positive to negative, which means going from positive to negative. The potential drop, you can take it as minus E1. Positive to negative. Now here we are moving our finger, and see, when we are moving the finger, we have seen that current basically at here is passing in this direction, right? Current is going in this direction. How come we know that? In the branch it will be current, the same current passing through all the elements. So for in the loop we are going in this direction, so we are basically going opposite to the direction of resistance, which means potential drop will increase. That will be a positive value when we are going opposite to resistance. See, opposite to resistance it is. So that is plus, let's say the current is I1. So potential difference is I1 R1. As our fingers is moving opposite to the direction of current, that is I1 into R1 plus. What is then? Then we are moving our fingers in this direction, and then we see a resistance here. In the resistance, in which direction is current going? This direction is current going, and our fingers moving opposite to the direction of current flow. When we are moving opposite to the direction of current flow, when our loop is opposite to the direction of current flow, you can take it as a positive potential difference. Clear? So that will be positive. And what is the value? I1 plus I2 passing through resistance R1. That is I1 plus I2 into capital R. And we are coming back to the same point. Now what is the value? This is the algebraic addition, right? This can be equated to 0. Clear? Or now I can take E1 is equal to so and so value. One more loop we will do. This is the loop. By this, your concept will be very clear. Now loop, which one is the loop? Loop A, then resistance, then B, then let's say this is R2, okay, R2, then SL, E2, then coming back to A. Can you tell me the equation? Our fingers is moving in this direction. Now movement of finger or the direction of loop and direction of current is the same. So in the direction, potential drop will be negative. That is I1 plus I2 into, that is the potential drop here, right? Into R minus. Now we are coming in this direction. We are seeing a resistance. And in which direction current is going here? Current, we have already marked the direction of current here in this branch. In all part of the branch or all elements in the branch, it will be the same current passing in the same direction. And our direction is I2 here, and even the movement of the direction of the loop is also same. So I can take it as negative because our fingers are moving in this direction and even current is also in that direction. So it's negative. Negative I2 into R2. Now we reach here. When we reach here, we are moving from negative to positive. Now from negative to positive, it is positive potential difference. That is plus Q2. Then we are coming back to A. That is 0. Now we have added all the potential differences and equated to 0. This is the meaning of loop rule. We will take one more loop. Okay. By this, your all concept will be clear. That is from a loop, from A, then cell E1, then R1, then from through B, then R2, then E2, then back to A. So loop like this. Now when we are starting from here, we are moving our fingers in this direction. We have reached the battery. From battery it is positive to negative. So positive to negative, what it is? Positive to negative. Negative is the drop, minus E1. Now here we are moving in this direction. Current is moving in this direction. We have already marked the direction of current I1. As it is opposite, then that should be positive I1 into R1. Now we are moving, we are passing B, then coming to R2. In R2, our loop is in this direction and current is also in that direction. So potential will decrease. Both are in the same direction, right? Minus I2 into R2. Now we are moving our finger from negative to positive. It is voltage gain. So potential difference gain. That is positive E2 plus positive. Then we have came back to A, that is equal to 0. Now for any loop, you can formulate equations like this and solve it. Then you will be able to get values of I1 in current in each part of each element of the circuit. Okay. Next we will see a numerical based on Kirchhoff rule, where we will apply rule number 1 and rule number 2. Thank you.